Okay, so in this lesson, we're going to combine horizontal stretches with horizontal reflections, and it's actually quite a simple process. So before we do that, let's go through this function one more time. Y is equal to f of b times x. Now, this is a function being horizontally stretched by a factor. So my stretch factor is going to be 1 over b. Okay, so by now you should be quite familiar with this. We looked at two cases of my b value. The first case is when your b value was greater than 0. Okay, so in this situation, your graph looked a bit narrow. Okay, so it got skinny. All right, and your second case was when your b value was greater than 0, but it was less than 1. So in this situation, your graph actually got a bit wider. Okay, so that's what we looked at so far. The third last case I want to take a look at in this lesson is when your b value is less than 0. Now, when your b value is less than 0, you still have a horizontal stretch. Okay, and that horizontal stretch is still going to be 1 over b. Okay, but now that it's negative, what's going to happen to the graph now is not only do you have a horizontal stretch, but also a horizontal reflection. Okay. All right. So let's see this type of behavior in action here. So let's go to the next slide here. So to reiterate here, when your b value is less than 0, there is a horizontal stretch and a horizontal reflection happening at the same time. But what's really neat here is that the process of performing a horizontal stretch and a reflection is actually it's exactly the same thing you've done when you perform a horizontal stretch. And remember, when you performed a horizontal stretch on a point xy on the original graph, what you simply did was you took your x coordinate and you divided it by your b value. And of course, your y values all stayed the same. So here we go. Here's my graph here. It looks like some sort of radical function. And we want to sketch the graph of y is equal to f of negative 2x. So if we take a look at the transform function y is equal to f of negative 2x, let's find out what our b value is. Okay, so to find the b value, sometimes it helps to compare it to the general case. Okay, so looking at these two functions, it's obvious that your b value is negative 2. Okay, negative 2. So what's happening in terms of my graph here? Well, we're going to have a stretch factor of 1 over 2. Okay, so the reciprocal of b, but that negative also creates a horizontal reflection. So we have a stretch factor of 1/2 horizontally and also horizontal reflection. Okay. Okay, so let's go ahead and perform this transformation. So just to review here, once again, any point on the original graph is now going to become x over your b value. And remember, our b value was negative 2, and your y value stays the same. So keeping this in mind here, we're going to pick 3 points on the original graph. So I'm going to pick this point right here, 0, 0. Okay. I'm going to pick a second point at 4, 2. Okay, and a third point at 9, 3. Okay, so keep in mind what is happening to these points here. Well, all your y coordinates are going to stay the same, but all your x coordinates are going to be divided by negative 2. So 0 divided by negative 2, 0 is the first point. Your second point is going to become 4 over negative 2, 2. And then your third point is going to be 9 over negative 2, 3. Okay, so obviously these points, they're a little ugly. You want to simplify it a little bit more. So 0 over negative 2 is going to be just 0. So see if I can fit this in here. So 0, 0. So that point didn't change. 4 over negative 2 is going to give you negative 2, 2. All right, and I'm going to draw this over here. 9 over negative 2 is going to give you negative 4.5 and comma 2. Okay. Oh, sorry, comma 3. That should be positive 3. All right, so there are our 3 points, and let's go ahead and graph them. So 0, 0 is a point that stayed the same, so that's what we call invariant. Our next point is negative 2, 2, so right there. And finally, negative 4.5, 3. So right there. Okay, so if we sketch our graph, it still should look like a radical function, but it's going to look something like that. Okay, so there is my reflected and horizontally stretched graph. Remember, in a horizontal reflection, you're treating your y-axis as if it's a mirror. So that's it. That is my lesson on performing horizontal stretches and horizontal reflections.